Ladies and gentlemen, welcome back to the afternoon session of Rackspace Solve San Francisco. Here once again is your host, John N. Gates.
You show the lights that stop me, turn to stone. You shine me when I'm alone.
Well, welcome back. Welcome back to the afternoon of Rackspace Solve. I hope you had a good lunch, had a good conversation out there. First presentation here this afternoon is going to touch on the topic of containers. Not just touch on it, go deep on containers. Containers are changing the way we architect and scale applications. Next presenter is an expert on containers. CoreOS is a lightweight Linux operating system available now in the Rackspace Cloud control panel. And here's a little video with a little bit more on CoreOS.
Brandon Phillips and I started CoreOS with the primary objective of seeing what we could do to fundamentally improve the security of the internet. CoreOS is a Linux-based operating system for running really big server deployments. We built a lot of different pieces of infrastructure technology that are meant for helping companies that want to run in this scalable, secure, modern way. We've seen CoreOS be picked up every major cloud service provider, as well as on bare metal, on virtual machines, kind of anywhere you can run a Linux server. CoreOS has been quickly proliferated into all of those environments. Rackspace was the first cloud provider to natively support CoreOS. It's very, very simple to get going. You go, launch a server. C is one of the top in the list, and so it's right there for you to click a go and you can launch it. And one of the neat things about using CoreOS is you don't really think about a particular version. You just select the level of stability that you want. Do you want patches right away, or do you want sort of after they've been tested a little bit more? And from the get-go, Rackspace has supported all the different options for that. As these services progress, there's sort of a natural, one step at a time way that we'll see infrastructure improve. Okay? First, companies were running their own infrastructure in data centers. Okay? Then companies were running their own infrastructure on cloud, but it essentially was the same server you had in your data center. It just provisioned a little bit quicker and maybe it was a little bit cheaper, right? The next step, and where we're seeing with managed cloud, is you're running infrastructure like you did before as a normal server, but you're actually having other organizations, Rackspace, take care of that for you, because Rackspace is better at sort of choosing one way to operationalize management and do it for a whole bunch of customers at once, and they can do it at a lower cost than an individual ops department could.
So with me here on stage is Alex Polvi, co-founder of CoreOS. Alex, take it away.
All right, thank you, John. All right, hello everybody. Welcome back from that wonderful lunch. Let's start talking about all this stuff. So here's what we're going to do today. First, I'm going to give you a little bit of the spiel on CoreOS so you get an idea of what's going on there. And then I'm going to stop that and start talking about a bunch of other companies' products. Something a little bit different. It's hard to represent other people's products, but I'm going to do my best and sort of give you an overview of everything that's going on right now in the industry as it relates to this movement around containers and distributed systems and kind of this whole thing that's going on. So, quick background. My name's Alex Polvi. I am the CEO of CoreOS. I'm a former racker. I jokingly say I still bleed red. But don't we all, right? Yeah. Anyway, we all bleed red here, definitely. I was previously at CloudKick, which Rackspace acquired, and that's how I got to CloudKick, or at Rackspace. And then before that, I was at Mozilla, kind of in the early days of Firefox. CoreOS is an early-stage venture-funded company. Our investors include Kleiner Perkins, Sequoia Capital, Andreessen Horowitz, and then we did Y Combinator as well. Greg Crow-Hartman, who's the Linux kernel stable maintainer, helps out on the project, and our team, is from Rackspace as well as a number of other kind of notable infrastructure folks. So, this is our sweet spot. This is the point I'm trying to make. We've put together a number of open source projects. These are the more famous ones. CoreOS, our namesake. We put out a container runtime at the end of last year called Rocket. Won't really get into that today too much, but it caused some excitement. And then etcd is a distributed key value store and is kind of underpinning of a number of distributed systems that are being built today. I'm sure Rackspace is a etcd user in some form, as well as CoreOS and these other components. So, what is CoreOS and why did we start building it? CoreOS itself is a lightweight Linux OS meant for running these big distributed systems. It took a lot of the learnings from from building these things at Rackspace and previous companies and sort of compass them into the ideal platform for building these large platforms on top of. Kind of 3 core value props of it are the way we do patch management and updating. It's a distributed operating system, meaning that you don't have a individual machine failure. There are individual hosts, but it's part of a larger system. And then it's container native. And we do that it's a requirement, meaning you have to run containers if you run CoreOS. The whole kind of excitement around containers and all this stuff is very timely and great for our products. But I wanted to share, why did we start building it in the first place? Like, why does a startup go and start building another Linux operating system? So who here remembers in 95 or so, no, it was like 2002 or so, when Internet Explorer dominated the internet. That's what allowed Firefox to kind of come out in the first place. It was this kind of idea of, let's take back the web, let's build a lightweight, more secure web browser. Internet Explorer was getting hacked all the time at that point. There was these Patch Tuesdays, and IT departments would scramble around trying to patch all their desktops, and it's just a total mess. When Chrome came out, they did something quite a bit different than both Firefox and IE. What Chrome did is they automatically applied security patches for you without user intervention. So this freaked out all these IT departments because now you have Google essentially controlling your browsers. But what we found was that Google was better at more centrally managing a patch to an individual browser than any individual IT team could be. And because of that, I believe we got the biggest step function in front-end internet security that we've ever seen. Essentially, when there was an issue, you could, bam, update everybody pretty much overnight. And then when Firefox and IE followed suit in this, as they do today, not only do we have the most secure front-end web, you don't hear about big exploits on the front-end web side. We hear about them on the back end a lot, but not on the front end. And also we get things like HTML5. Like all of a sudden your webcam just lights up in your browser and it starts to work. And that's because these guys are able to push the standards out very, very quickly. So on servers, we got nothing like this at all. On servers, state of the art is get it running and don't touch it. So we were like, hey, what if we could build a server that automatically updates itself? It's disruptive enough that it's orthogonal to the way that people think about infrastructure. But if it works, it unlocks a lot of value. And so that's what we did. And when we started shipping CoreOS, it's already started to work. These are two vulnerabilities that have come out since CoreOS has been released. I would like to step back for a moment on this. Security vulnerabilities have gotten so bad that we now brand them. I mean, really? Like, Heartbleed is like a quasi-household name. I don't know household, but you know what I mean. It's something people know, and so I think this just shows how bad these issues are actually going. But with CoreOS, we fixed this, and hours after the patches were available, we roll it out to the tens of thousands of machines that are under management of kind of this system, and whether they are on Rackspace or on bare metal or on a Vagrant machine on your laptop, you get the updates and they're automatically applied and serviced, and you're fixed. And so we were pretty proud that the system is actually working and seeing quite a bit of adoption, and our initial goals around seeing what we could do to secure the internet are happening. So updates are the first piece of how you build this kind of system to secure the web. The second piece is containers. And the reason containers are important are because you need to be able to separate an application dependency from a host dependency in order to update things. It means every single application we want to update individually. Okay, and if we can do that, then we won't break things as often, or if we do, the things we break are isolated. And so that's why containers are an important component to CoreOS, because that's what it allows us to sort of separate each of the applications into their own little set, so that we can kind of service them and update them. Now this is where I hit the pause button on the CoreOS shtick and say, okay, so that's enough of the CoreOS thing. We have a lot that we've been talking about, but now I'm going to talk about all these other things instead. Okay. So what I'm going to talk about with each of these guys is what they are, sort of how they're using containers and distributed systems, sort of this new way of running infrastructure, and then touch on how things are being monetized too, because I think it's kind of interesting for a business conference to talk about how people are trying to make money with this stuff or are making money with it. So let's get into it. The reason all of this is happening is because a container is innately about thinking about an application first instead of a server. All right, so kind of the traditional mindset of running infrastructure is I have my server here and I have my server here and I need to configure them to talk to each other and so on. But with a container is like a systems guy's word for an app, like an app on your phone, but it's a container, it's like an app on a server. And this app-first thinking is what's causing kind of all the change. When you think about applications first, instead of thinking about the underlying infrastructure, you can change a lot of stuff. You can change how it's deployed, you can change how security is done, kind of everything changes around it. And so because of that, it's creating a bunch of new open source projects. There's a lot of open source projects emerging right now. And there's a bunch of new commercial products also emerging at the same time because of this change, okay? And one thing I would like to call out that is sort of an undertone of this whole industry right now is interoperability. It's almost unspoken, but it's actually the first time in infrastructure that this has happened in an almost ubiquitous way. We are getting actual application interoperability between all these different environments, meaning as an end user, I can package my application once, and I can deploy it to Rackspace or to my environments on-prem and do that relatively consistently. When we were trying to do this at the virtualization layer, it didn't quite work because there's VMware and there's Xen and there's KVM, and those things just aren't interoperable. But when we bring it up to a container level, to the application level, we can abstract out the underlying hypervisor or bare metal, it doesn't matter, and we get app interoperability for the first time. I think this is probably one of the most exciting things that's coming as a result of this shift to thinking about applications first, but it's happening, yay. Okay, so back to these guys. Let's get into it. So first, let's talk about Mesosphere. So Mesos, okay, remember I'm going to do 3 things for each of these guys. So first, Mesosphere, what is it? Mesosphere is the commercial company behind an Apache Software Foundation project called Mesos. Mesos is a cluster management system. It allows you to sort of aggregate a pool of servers as a giant set of resources. It was inspired by Google's Borg project, which is their internal cluster management system for running Google. And Mesos is an open source implementation of that project. Their namesake companies are like Twitter and Airbnb run Mesos in their own environments. They use containers because they want a portable unit that a customer can go and take and then just run inside of this Mesos cluster management system. Okay, so again, this portable unit is kind of their key need there. Their business model is an open core business. They have a open source base, and then you can buy the enterprise kind of edition version of it that has enhanced features on top of it. So they're an early stage startup as well, and that's what they're up to. Next one, let's talk about Cloud Foundry. A little bit of a bigger company here. Cloud Foundry is a product of Pivotal. Pivotal was a spin-out of VMware. Cloud Foundry's actual product is a platform as a service. It likens itself to like a Heroku, if you're familiar with that. They use a container in the same way as Mesos. So they take a container and deploy it into their infrastructure. The neat thing with this app portability is, technically speaking, I should be able to take my container that was packaged on Cloud Foundry and go and run it in Mesos if I want to, which as an end user, is a really good thing. And that's Cloud Foundry's actual product. And then their business model is a open core as well. So on open source core, enhanced enterprise features on top, similar to Mesos. All right, that's Cloud Foundry. Next one, Amazon. So Amazon, I think we all know what AWS is. As it relates to containers, what Amazon has done is they've built a service which essentially takes the existing cluster management system. It's called Amazon, I think, Container Service, and integrates the ability to execute a container on a running virtual machine. So all all that's happening is a cloud instance is booted up and then a container is ran on it. Now it's abstracted away a little bit with APIs and so on, but that's really what's happening behind the scenes. Again, the standard container unit is in there, but at the end of the day, you're on Amazon's kind of proprietary stack, nested inside an existing virtual machine. So it's essentially an abstraction on booting a virtual machine for you and then installing a container on it. Make sense? They don't charge for that service at all. They just charge you for the underlying resources that you use because of it. Next one, Kubernetes. Kubernetes takes the award for most obscure product name, I think. I don't think they had a trademark violation on that one. But this is an open source project put out by Google. It's Google's version of their internal cluster management systems. This one actually likened most closely to kind of the Rackspace and OpenStack strategy, where Rackspace is cloud, once run product, and then they open source a piece. The difference is, again, it's this application tier of infrastructure instead of a server tier of infrastructure, which is similar, which is where Rackspace and all the existing cloud providers are right today. So Kubernetes is an open source project. Google's not directly monetizing Kubernetes at all, outside of hoping that once people use Kubernetes, they'll go use the Google Cloud. So that is Kubernetes. It's an open source project, Apache 2 license, but controlled by Google. Docker. Docker itself is the reason a lot of folks are talking about containers in the first place. Docker is a container system. I think the tagline is a distributed platform for running containers. I think what most folks know Docker for is the ability to download and run a container and then add it to an existing environment. Docker's business model is they have a hosted service for pushing and sharing your containers with your server infrastructure and your other teammates. And then they have announced that they're selling on-prem enterprise products as well to sort of support that. Docker itself is an open source Apache 2 licensed product, but the services that Docker interacts with are either hosted as a software as a service or potentially purchasable on-prem, although that hasn't been released, only announced. So it's TBD what those products actually look like. Okay, it's Docker. And Rackspace. Rackspace has been using containers for a long time. I don't know if folks know this, but products like Cloud Database were built on top of early container technology, kind of pre-Docker and pre this whole movement. And I was talking to Jen Gates, and he said that we really want to get comfortable with these technologies internally because our goal is to help companies run this stuff. So as Rackspace has been running this in their own production for a while now, I can only presume as an outsider that there would be something, but TBD. We'll see what happens there. And then CoreOS, our own thing. So in the effort to kind of combine showing off CoreOS and Rackspace at the same time, we have a little bit of video here just showing how you can bring up CoreOS in in Rackspace. Before I get into that, I did want to talk about our model. So we use containers in the OS. I already told you what we are, but in terms of a business model, we're similar to, well, no, I don't know, I think we're a little bit distinct from all these guys. We have these open source components, those things I told you about, CoreOS, Rocket, etcd, and then we have commercial applications, which are implementations of that stuff for companies that would prefer to sort of buy the whole solution off the shelf instead of piece together all the open source. And that's the model that we're working towards. And then let's show the video here. Is this going to start going? Help me out. Does it go? Nope. OK. We're going to jump right ahead. So the video, just a piece of trivia on the video. When I was at Rackspace, that was a component that I worked on. The team has made it much better since the time I was there. But that was a product we actually worked on. So to be able to launch CoreOS inside that control panel was kind of a neat thing for the folks that have worked on that. The app container specification is something that we've recently been spending a lot of time on. Containers are emerging as this sort of portable unit between all these environments, as we showed. But yet there's no kind of standard that's written down about what a container actually is. And so our hypothesis is that for containers to reach a true kind of standard ubiquity in all these different environments, we actually need to document a standard, something like HTTP. These are standards that are just plumbing of the internet. We've put together a proposal called the App Container Specification. We've ran it by all of those parties that you've seen there, along with a number of other folks in the community to make sure it's a really solid spec. And if you're interested in kind of contributing to the open source interoperability piece of all of this story, we would love your help. on making sure that this thing is good, because once we call it 1.0 specification, we can't really change it, and to change it, it's a big deal. But this is sort of, I think, the final piece remaining before we have containers, is this like ubiquitous standard that can be used by a bunch of different projects and built and ran independently of how they are implemented. The specifications required for that. So I'd encourage you to get involved if you care about open standards and those sorts of things. So in summary, the big change that's happening here is applications are becoming the primitive object within infrastructure, not the server. It's moving one level up. And because of that, we're seeing a flurry of open source and commercial projects emerge around that. And because of the work that everybody's doing around this, we have our first shot at true application portability between all these environments. So thank you so much. And I will take it back to John. Thank you.
Thank you, sir. Thanks, Alex.